So unit 8.2.6 is called similarity. Well, what does similarity mean? Well, if you look at my screen, initially what we started with, we started teaching, we started talking about this early on. We said if I had 7 plus 3 equals 5 plus 5, well, is that a true statement? The answer is yes, it is a true statement. However, it's not completely congruent because 7 is not the same thing as 5 and 3 is not the same thing as 5. But I do know that 10 is equal to 10. So is it congruent? The answer is no, but 10 equals 10 would be considered exactly the same. So what we're looking at in this section is simply stated this piece right here. Well, what does that mean? Well, simply put, is even though they're not the same, they are similar. They're similar. So given that, we have two images here. We have these things that look like L's, and we have the triangles, and then this other crazy looking figure. And our point here is to find out the dilation factor and a transformation or a rigid motion, a rigid transformation that takes it and puts it on the other. Well, first thing I'm going to look at is corresponding sides. So I know this side and this side are corresponding because this one is 2, this one is 4. It's on the back side of this little cutout 90-degree angle. So I know that this is congruent to this. Well, right now the measurement of this angle or line is 4 and this angle is 2. So if I'm going from this to this, then I'm reducing it by 1/2. So I know that I'm reducing it by 1/2. Initially it looks like this. I don't know what happened with my thing here. Initially it looked like this. Let me undo this because it's kind of crazy. Things just changed on me. Maybe I can't. But I know that it is half the size, and I actually had to rotate it in order for it to become the same type of image. So I had a rotation of 180 degrees, and now I can see that there's double that, double that, double that, double that, and that becomes my similarity. So triangle, the small triangle is half of the large triangle. Well, let's go from this triangle to this triangle. Well, in order for me to get there, once again, I know I'm going to have to move it, but the first thing I'm going to have to do is actually rotate it. So now once I get it there and rotated, whoops. Once I get it there and rotated, there we go. I can see, well, this line is 1/2, this line is 3. So in other words, this triangle image is 3 times the size of this image, and I had to rotate it to put it on top. Well, now let's look at these two. I'm going to go from this one to this one. First thing I'm going to ask you is, imagine, if you would, a transformation that would take this image to that image. Could I reflect it? No, because this is the wrong place. Could I rotate it? Well, let's find out. They're not all going to be easy rotations to see, but this is a rotation. So if I rotate this and bring it over, drop it on top, I notice, look, it's got a length of 1, this has a length of 2, a length of 1, a length of 2, a length of 1, a length of 2, on and on and on. And this is 1/2 scale of the big one. And it took a rotation simply to put it on. So that's what this entire discussion is about in 8.2.6.